It's sort of traditional for Mark Stearman to give me a sort of bio that's a little off. And I look down here and there's no bio from Mark, and it really crushes me. But in passing, he said that, you know, perhaps I should make something up. So Mark Stearman from Lawrence Livermore National Laboratory. His new book, How to Install ZFS on Far Too Many Disks, it's climbing the New York Times bestseller list. Last week it was number 3. This week it is now number 1.5. Beaten out only by, I don't know, the sequel to the Da Vinci Code.
There's a new Harry Potter book coming out too.
Right. If you'd like to see Mark Stearman act, perhaps you should go see Avengers Age of Ultron on May 1st. You will see Mark in an uncredited role. He is appearing as Beard Man. So let's give it up for Beard Man, Mark Stearman.
Excellent. All right. Thank you, sir. All right. I checked the schedule from LUG last year, and I had this exact same time slot. So I think we'll call this the second annual How Long Can Mark Keep You from the Networking Reception? All right. Users want it all. They want capacity, as much as they can get. But they want it to be fast, super fast. And they want it to be inexpensive, or free is even better, right? And of course, you only get to pick 2. So choose which one you want to get. Users like what they like, right? It's your iPhone versus Android. It's your Mac versus Windows, your Ford versus Chevy, your Marvel versus DC, right? People are going to pick the things they like. They're going to stick with it. Me, I'm an iPhone, Mac, Ford, Marvel kind of guy, right? These are things we've actually heard people say. You want me to change my I/O? Are you serious? You know, I download that library off the internet. I don't know what it does, right? They're just not interested in changing their I/O applications. They're physicists, they're chemists, biologists. They're interested in the science aspects. They want to optimize their algorithms. They don't want to fool with I/O. So they're also using legacy applications that were written, you know, decades ago. They're just now optimizing for NFS. Now that Lustre's been around for 10 years, 15 years, maybe they'll start to optimize for that. So where does that leave us? We got small I/O, billions of files, overwhelms our metadata servers. We had a user that dumped 350 million files over the weekend to the file system, right? That doesn't help anyone, not even him. We've worked with the user. We've tried to give him tips on how to optimize, write to local disk, write to a RAM disk, move stuff to Lustre at the end. He doesn't care. It's not impacting his compute time. So he doesn't want to do anything. But we need more metadata ops somehow. DNEV1 is an option. But it's really not that much different than multiple file systems. If I have to assign directories to specific metadata servers, I might as well just build a few file systems and assign users to those file systems, right? Users could write to multiple file systems. That was the original envision that we had at Livermore when we started working on Lustre, 15 years ago, was that user applications could ping pong back and forth. Write one restart data to one file system, write the next one to the other, and bounce back and forth. That way you could get even and balanced utilization of the file systems. Do they do that? No. They camp on a file system. If that file system's down, they complain about it. They don't have any data on the other file system, right? And obviously, right, we talked about this, they don't want to change their I/O. DNE2 is better. Striping your directories, similar to what we do with the OSTs, is a better option. But again, you probably want as many MDS nodes as you have OSS nodes. And every app is different. Some users are very write-heavy. Some are read-heavy. Some use small I/O, some large I/O. Every application is different. It almost seems like every app should have its own file system. So why don't we do that? ZFS is awesome. We've heard about all the great features of it. ZFS is a pooled storage. It has a volume manager built into the software, built into the file system. So why not make multiple file systems within the pool? You could give them to every user. You could give them to a few users. There's lots of options. We've done this before. In 2013 at LUG, I gave a talk about migrating data on Sequoia. And we did that exact same thing. We stood up a second metadata server, created a second file system within the pools. We had lscratch1 and we had lscratch1.old. And we gave the users a month to move their data over. On one of our clusters, I moved some of that data for them. It was very painful, but it's doable. You could have multiple file systems within a pool. So here we have a typical tiny, tiny Lustre file system. Although with ZFS, those OSTs can be 100 terabytes each. So you could get a half a petabyte file system there on the screen. And so maybe we have a power user, right? We'll call him Barton. And we'll give him his own file system because he's a power user. He knows what he's doing. He wants to maximize his I/O in the best way possible, right? Then we have this other user. Let's call him Sims. He's taken all of his comics, he's digitized them, but he doesn't want anyone else to read them. So he takes every pixel of the image and makes that its own file. So he's got a whole bunch of 1-byte files, right? This guy's not going to play well with others. You need to give him his own metadata server, so the only person that he's hurting is himself. And he doesn't need a lot of space. So maybe you only put that file system on a couple of the OSTs. Maybe you want a GSS and Kerberos file system for sensitive applications. You could give them, or that user group, their own file system inside the pool, right? It's very flexible. There's a lot of things we could do with ZFS. And forget the Lustre level quotas. With ZFS, you can specify the size of a data set. So if you were going to create a file system for every user, why not give them a default quota of, I don't know, a couple terabytes, 4 terabytes, right? They have that on their desktop. So when you create the data set within ZFS in the pool, you can specify a size limitation on it. You could do that for all your users. Power users could certainly have a larger quota. You could give them more space. Manage it just like you do your home directories that might be on a NetApp or some other, Blue Arc, some sort of NAS device, right? Now, Lustre quotas might still be needed on a general purpose file system, so they're still available. But you can easily manage your space within the ZFS level and restrict the size of these per user file systems. And certainly you don't want them out globally. As I mentioned a few minutes ago, the OSTs each take a little bit of space on your clients. If you have 1,000 users and 1,000 file systems, you're not going to have any RAM left on your clients. So for the compute nodes, it's very easy. When the job launches, if you're using something like Slurm that has an epilogue and a prologue, you can use the prologue to mount the file system for that specific user only. At the end of their job, you can make sure all the data is flushed, unmount it. Login nodes become a problem. Data transfer nodes if you're wanting to put data into storage. So that's something we would have to think about. You could set up a cluster full of VMs, and as a user logs into the cluster, instantiate a VM for them. Or even better, if you can get the auto mounter working well with Lustre and finely tuned, that could solve your problem as well. But wait, there's more, right? Why just Lustre, right? ZFS is an open, scalable file system, right? That's what we're here for. ZFS can create any sort of data set within the pool. You could create an NFS share. We've actually done that on one of our test clusters where we have SSDs local to the nodes. Users are writing very tiny files, so we're trying to evaluate what if we shared an NFS volume from the pool and users wrote to that versus writing to Lustre versus writing to the SSD. What are all the options? How can we tune their applications better? Or what if you're doing something kind of like Hadoop? You could set up an HDFS file system within those pools, mount that locally to the OSS nodes. Not that I really recommend your clients running stuff on the OSS nodes, but it's a possibility. If you have control of your user and your app, there's lots of options. So at Livermore, we have about 100 petabytes of Lustre installed over 10 file systems. And those range from a Great Dane down to a Chihuahua. Got a number of cattle dog size in the middle. So if you guys like walking dogs or maintaining puppies, or if you're a cat person, we can do that too. We're hiring. So you can come work for me and work on fun stuff like this. So that's all I had. Questions? Ideas? Yeah.
So volume management, a lot of times it delves into details
Uh-huh.
about how, which sections of the devices you're taking, and because you want to maintain the performance of things, right? So have you done work in that area? Does ZFS make it easier, or is it probably still the same set of issues? You have to pay attention to doing garbage collection or management of the, the physical block devices underneath what you're virtualizing.
So from everything I've done, when you create the pool, it's how you create the pool is what's really most important, right? And which disks you're picking to put into those VDEVs. Once you've done that, I've found the pool to be fairly consistent performance-wise. Up until you get about 70% full or so, performance starts to degrade. But we see a very flat performance. And I think Brian Behlendorf mentioned that there are people on the ZFS mailing list that have created like 10,000 pool or data sets within a pool, and they're not seeing issues due to those kind of things. So
Manage utilization 70%.
So we do that via purging. The question was, how do we keep our file systems below 70%? We have a purge policy. If you haven't accessed your data in the last 60 days, it's eligible for removal. And we can walk through the file system and start removing files. I find it faster and easier to ask the hotline to contact the top 5 users, because they typically have 90% of the space. And they know how their data is organized. They can remove it much faster. They can do an RM star in a directory, and that's way faster than me statting every single file in there, especially if there's 350 million of them. It can take us a month to walk through the file system, right? Most of our file systems have a little over 1 billion files on them. So it takes a long time if we have to crawl through. It's much faster if we ask the users to do it.
So, but do you have a target utilization, so 60% is, try to keep it at that? Or
we'd usually stop purging at about 50%, 60%. Oak Ridge guys are a little more aggressive in theirs. They'll purge anything that hasn't been touched in like 14 days, right? And they'll purge it until they're done purging, right? So you manage your storage how you want, and whatever your users will accept before they come with the pitchforks and torches.
Right, well, we don't purge any, and so that's kind of our strategy, but we do make the contact and try to manage things, but we do see, once you're getting up into the 80-90%, like, you get some serious fall off, but.
So that's the nice thing about ZFS too, you can always add more.
Yeah.
If you have the budget, you can add more storage onto it, and it just gets bigger, and now you're at 50%, right? If you double your storage, right?
Thanks.
Yes.
Hi, Mark. Very interesting idea. How do you think it would play into your administrative portfolio, let's say, right? Because if you have, let's say, 1,000 users and you're going to do 1,000 separate file systems, how do you manage that dynamically? How does that tie into user account creation and removal, project removal, things like that?
Yeah, so currently we have a script that runs anytime a user comes in, shows up in the password file. We just have a script that creates their directory within all the Lustre file systems. So it would be something we would have to script to create the file systems. I mean, it's the same commands every time. It's just a different mount point or directory to create new file systems. I don't know that I would actually advocate creating one for every 3,000 users that we have. That seems a little onerous. But I certainly think having a general purpose file system for the 2,995 that are just happy, not doing a lot, running very small jobs. But for those 5 power users, the 10, you know, it's easy to add 10 or 20 metadata servers, add a few files. If you're doing the auto mounter or even using your scheduler to mount and unmount, you can still get that mount point mounted, even if it's a general purpose file system. It would certainly take some work, but we already do that with project space on our NetApp NFS filers, right? Users fill out a form, they request project space, they get a quota. We have scripts that we go through and create the queue trees on the filers and do all of that. So to me, it seems like it would just be an extension of that, right?
Are you using ZFS send and receive to offline user data?
We are not. We have an HPSS archive for stuff that the users want to keep. Our file systems are scratch, so if the data is lost, the data is lost, right? Sorry, too bad. But the HPSS archive, we have data from the 60s. We don't delete anything out of it. We tell the users anything they think is important to put into there. And so we have a cluster of data mover nodes that they can log into, and there's a variety of tools, HTAR, NFT. They could just FTP into the archive. Right? There's a variety of tools they could use. So we leave that on the users to put what they think is important.
You make use of ZFS sparse files to help manage space or to pre-allocate zones?
No, haven't done any of that yet. We do leverage snapshots. Whenever we do an update to our OS or new Lustre update, we'll take a snapshot of the cluster before we do that. That way if something goes wrong, if it crashes or is corrupt, we can always roll back to the prior version.
How do you actually manage the creation of the MDSs for each individual project when necessary? And are they virtualized? Are they hardware on the hardware directly?
I don't know yet. That's a good question, right? We're not actually doing this in production today.
Oh, okay.
It's an idea that we're floating around, but we haven't actually done it yet.
We had a code that was horrible on Lustre, and we would have loved to have just kicked them out because we were like, fix your I/O.
Right.
No, it works well on other competitors' products. We're like, so what? We don't have that choice, and they affected everybody on the file system. It would have been nice to have put them in a corner and let them beat up on themselves and not affect others.
When we bought Sequoia 3 years ago, we had intended to do failover on our metadata servers, which we hadn't done prior. But then, of course, the lack of multi-mount protection has kept us to shy away from that. We don't want to trash the pool on the MDS accidentally. But when we bought the hardware, we had extra MDS nodes in there, so it was a fairly easy thing. What we first tried actually was to create the metadata server, or the MDT, for the second file system on the original MDS. But having the MGS on there and both MDS starting all at the same time, it crashed. I think there was a bug there. It's probably been fixed at this point, but we haven't tried this again. So potentially you could just stack multiple ones on the same MDS node. But we had an extra server lying there, so we just installed it on there. Both of them were cabled into the same JBOD, for shared disk because it was intended for failover. But that's what I would do. If we push forward with this, buy a cluster of MDS nodes, 5, 10, 20, however many we need, and put them in pairs, give them their own storage, right? Your storage requirements certainly go down if you're only putting a single user on a file system, right? And that's another way to limit them is to say, look, you've only got 100 gigabytes worth of storage. That's only going to get you 300 million files or something, right? Yeah. Anybody else?
How resizable are these Lustre volumes made out of pools? If you made a file system for some random user, could you shrink the Lustre volumes out of the pool or dynamically grow them?
So that's what's kind of weird. Within the pool, it's a shared resource. So if you create a second data set within there and you start filling it up, the other one goes down, right? So your file system size will change over time if you don't put any limits on them. It will just take storage as it needs it. If you limit the size of the file system via ZFS, then it'll be a fixed size, and then the other file system would use the rest of the pool. So it will change. Every time you do a DF, both file system sizes are going to start changing on you. And it will look a little weird. But I guess I should say it automatically resizes. You don't have to do anything to shrink it or grow it. There are ZFS commands to limit or change the size of a file system within the pool.
So my question is, you have only so much bandwidth to your disk, and are you planning on dividing that up too? Or are you just concentrating on the metadata operations?
Well, so I think the problem for us right now is that we're metadata bound, right? I can watch via LTOP, and I can see that we're doing a few thousand opens and closes, get adders, set adders, and then I look at the bulk transfer rate for the whole file system, and the users are doing 2 gigabytes a second on something that is potentially 100 gigabytes a second, right? The OSTs just aren't that busy, right? The users are creating these teeny tiny files. They're not utilizing the OSS node bandwidth. So I think there's plenty to spare. Which is why this becomes an interesting concept, is get us more metadata, try and balance it a little better.
Okay. I have run into issues where the OSS bandwidth is exhausted by people reading really small files over and over and again. So
Yeah, I would say if your OSS bandwidth is limited, you certainly wouldn't want to do this, right? You wouldn't want to. Although that being said, right, if you're taking one file system and then splitting it up into multiple ones, you're still having the same user set, right? You're not really changing the bulk amount of users on the file system, but you are getting more metadata, right?
When you do snapshots, do you do snapshots to the MDS and the OSSs individually?
Mm-hmm. Well, in parallel.
In parallel.
So yeah, if we're going to do a system update, we stop Lustre on all the servers, so they're in a consistent state, and then run the snapshot in parallel across the cluster. Then we apply the update, reboot.
So then all the snapshots have like the same timestamp on them and everything too.
Yeah.
So you're kind of doing a human consistency check.
Yes, it's just part of our update procedures. It's not like an automated cron type thing. We're not doing it on a regular basis. But yeah, it's a manual step in our update process. It adds a little bit of time because sometimes Lustre doesn't want to stop cleanly, right? So it might take 15, 20 minutes for all the services to stop. But once it does, our init scripts export the pool at the end of it, right? So we know they're all in a consistent state at that point. We import the pool, take a snapshot, and then we go ahead and do our updates. And that way, if we did roll back, it would be just like we stopped Lustre and started it up again. Yeah. All righty.
All right, ladies and gentlemen,
Great. All right, thank you.